Hello and welcome to the first part of the series of screencasts about Qt Automotive Suite. This is the first part and we will talk today about the starting the system. Basically, this is the Neptune 3 UI, which uses also other components from the Qt Automotive Suite under the hood. So we will take a look how it works on a desktop. I am currently running here KDE desktop on Linux. But Qt Automotive Suite also runs on Windows desktop and on macOS. We will take a look on this later. Plus, it certainly runs on a number of embedded devices, which will be shown in the screencast as well. Okay, so if you start Qt Automotive Suite, you basically have two choices. You either have binaries pre-installed from the Qt installer, or you have your own build. Both is mentioned in documentation, and speaking of the documentation, please take a look on the documentation. This is a part of the standard Qt documentation. It contains a lot more details compared to what will be covered in the screencast. So if you use a Qt installer, then binaries of source code, certainly of the Qt Automotive Suite, is usually installed as all other Qt packages. So it is a standard Qt folder in your home folder. Then you select the version number. So let's select here 513. And then you have a platform name, which is also standard in Qt installer. And then after the platform name, there is a subfolder called Neptune 3, which contains the binary. We will start in this screencast. This is Neptune 3 UI. Plus some other binaries, as well as configuration files with the YAML extension. We will talk about them later, but now we will switch over to my own build. This build is based on 5.14 baseline, and this is the currently latest and newest one. It is not released yet, but the screencast will be based on this to show the most recent features and updates. So in this folder, if you build it from source code, you also have almost the same content. You also have binaries for different purposes, and also the configuration YAML files. So let's start the Neptune 3 UI, the binary. So it is started as a binary. It is also based on libraries from Qt Application Manager. And this change was made some releases ago. Before that, it was just a viewer basically with the main QML file, and the viewer was basically the application manager itself. But we transited now this to be a real binary. There is also explanation about this in documentation. So if you started on the desktop, you will see multiple top-level windows. Let me fetch the third one, multiple top-level windows, which actually represent different displays on embedded target. So the desktop is meant to be a development environment, and here different display surfaces are mapped to top-level windows to basically facilitate the development. And another helper on the desktop is also the possibility to scale windows to a certain comfortable size. So as you see, if I change the size of the window, its content is scaled, but it still retains the aspect ratio. So this is also made to retain the features of the UI as well as its layout, and basically make it the same as it runs on the device. So you have three windows in parallel. They all represent, as I said, different display surfaces. So they actually are run by one application, and this is one virtual surface. We will talk about this later when we talk about the system UI. What's important to know right now is that all windows can be certainly closed, and the whole Neptune will be closed with the last window. So you can close, let's say, head-up display, cluster, and the process is still running. So when you stop Neptune, then it will be closed as well. Okay, So let's take a look in the next section how it is running on macOS and Windows, and then on embedded device, and then we will switch over to the next parts, and this will be the system UI. Thank you. On Windows desktop, you can start Neptune 3 UI from Explorer. So you go to the installation folder of Qt, select the version, select the platform, and go to Neptune 3 folder and start the wrapper script, not the Neptune 3 binary itself. The wrapper script sets up a few paths which we need to preset so that all components will be found. Let's resize top-level Windows a bit so that we can see things better. And Windows is a single process platform because Wayland is not supported here. But thanks to features in Qt Application Manager, it makes it all transparent. So this is the indication that it's a single process. You can see also version and platform information here. And if you go to the Apps tab, actually we will talk about this dialog later on in one of the later parts. You can still manage here the life cycle of apps. You can still close them and relaunch them again. And this is again powered by the flexibility and features of the Qt Application Manager, which makes it fully transparent for UI developers. And you can close the Neptune by closing the command line prompt. On Mac, it looks like almost the same as Linux, and it actually feels the same in that sense here. So you also go to the same path here and launch Neptune 3 UI from command line. macOS is like Windows, also a single process platform for Qt Automotive Suite, because for the same reason Wayland is not supported here on the Mac desktop, and still Application Manager makes it possible to basically not notice the difference from the UI development. So you see here an indication single process still, and there's still information about versions and platform on the bottom of the dialog, which we'll talk about in more detail later. And you still can control the life cycle of the apps from the Apps tab on the System dialog. So start them, relaunch them, and let's set it up to actually recover. Later we'll use the settings and talk about this, as I said, in one of the later parts of the screencasts. Here we just see how the same build of Neptune and Qt Automotive Suite starts on different desktops and different operating systems. On NUC embedded target, and we use here two video streams recorded separately from two displays connected to a NUC. Now you can see a brief prompt from the bootloader, and then Linux starts to boot on the target, and then Neptune 3 UI shows up on two displays. The startup is integrated in the systemd environment. There is a service. We will also see it later in some other parts of the screencast. And here you see that it runs in multiprocess mode, and the same information, different information, but in the same tab shows up on the system dialog. Welcome to the screencast about the system UI of the Qt Automotive Suite. In this screencast, we will take a look on the interaction and visual concept of the Neptune 3 UI, as well as content, take a look on the content of all the screens and windows, and we'll talk about the role of the system UI in Neptune 3 UI and in the system in general. As we talked in previous screencasts, on a desktop, Neptune is shown as 3 top-level windows, which represent the content of different display surfaces connected to embedded target. On a desktop, you can resize the content of the window. This is made for developer convenience, to simplify the development. Certainly on embedded target, the content of each of the windows stretches and fills the entire surface of a display. The windows retain the aspect ratio, the only scale, and they also have a certain split how they process input events. So the central stack or central console window on the right side is the only window which processes touch events and mouse events. So it can basically process the main user input. The cluster window on the left top side, as well as the head-up display here in the middle, they respond only to hardware key events, which is processed centrally. And we will talk about some of those key events, hardware key events, later. Maybe we can take a look on the central console and discuss the main areas of the window there. So if we go from the top to the bottom, on the top we have notification area, or notification center UI, which currently shows that there were 2 notifications in the past. On the left side we have a few visual only icons. On the right we have the system time displayed. Then we have an area with buttons, which also has the home button. The home button is always visible and it brings the user back to the home screen, even if an application runs in a full screen. And on the right side we have so-called quick launch buttons from the launcher, and the launcher itself can be opened by the right button with the hash icon. We'll talk about the launcher later. In the middle of the screen we have widget area. Widgets are surfaces owned by an application and showing the application content. We'll talk about the widget area later. What is important to know right now as well, that the content of separate areas actually represented by the application controls. So this is not a static image, this is a real application control. For example, we can emulate the call to Jody here in the phone application widget. On the lower side we have a plus button with which you can add more widgets or select which widgets you like to add. Maximum 4 widgets are supported on the home screen. On the bottom side of the central console we have climate application, which can be opened by clicking on this with the mouse. We also have a global volume slider, and we have a system dialog which can be opened by pressing on the Qt logo. We will talk about this dialog later. It contains quite some interesting information. Okay, in the next screencasts we will talk about the widget area, application launcher, and system dialog. Welcome to the screencast about the application launcher of the Qt Automotive Suite as a part of the Neptune 3 UI. So the application launcher consists of a few buttons on the home screen on the central console. These buttons are located on the top, in the top area, and they consist of the home button on the left side, plus a few quick launch buttons in the center side, on the run side as well. And on the most right side we have a button which actually opens the entire launcher, which also shows many more application icons. All those icons belong to separate applications. Applications are automatically populated here on the list, so they are also discovered on the Neptune startup automatically by scanning the file system and updating the database of applications. Plus, if you install application afterwards, which is also possible, and we will talk about this later, the icons also shown here on the list. You can sort this list and decide that you would like to put some of the application icons on the top row, which will be then the quick launch row. And you can activate the sorting mode by long pressing an icon. They will be highlighted in a light gray color. Then you can sort the icon, and let's say now we decide that general settings should be placed on a quick launch bar. So close editing and then close the icon, the launcher, sorry. And we got now the icon of this general settings app here on the quick launcher. If you open an application from here or from the entire launcher, it starts in a full screen. and it still has the quick launcher buttons as well as the home screen button always visible. So you can basically also return to the home screen, and you can also call the application back. So it will be put in the foreground. Before that, if you again go to the home screen, the application will be running in the background, but it's not shown on the display. As you can also see, if you have the application running in the foreground and occupying the full screen, there is still one widget visible. So one widget is always defined as being visible. You can slide this widget to the side, and then you have the whole surface of the display for the application. Welcome to the screencast about widgets as a part of the Neptune 3 UI in the Qt Automotive suite. Widgets occupy the largest portion of the area of the home screen. So the whole central area is used to display widgets, and widgets are thought to be a kind of viewport and quick access for different applications running in the background. So it simplifies the access to the application functionality, plus displays different data provided by the applications. The area of each of the widgets is actually rendered by the application itself. As I said before, it runs in the background, and on a home screen you can change the way how widgets are displayed, which widgets are displayed, as well as control the application itself. So let's take a look what we have here. So we currently have 3 widgets displayed on the screen. They have a bar on the left side with different icons, with the area on the middle of the widget. You can change the position of the widget and sort basically the display order. With the cross icon, you can dismiss one of the widgets from the widget area. This also mean that only the widget is displayed, the application remains running in the background. And with the icon on the top right side, you can run the application and start it in the full screen mode. If you go back to the home screen with the home button, you will see the widget again. You can also resize widget areas and basically change the proportion, how much of the screen surface is taken by a given widget. You can also see that the content of the widget is also changed, so application reacts on the change of the size of its widget shown on the home screen. And if you add one additional widget to the home screen, it is also adopted. So the very last widget, which is on the bottom, is always shown permanently, also if you have an application running in a full screen mode. For example, now we started the phone application in full screen mode, and the calendar widget is still shown on the bottom. You can also swipe the widget to the side, so will have the whole display and window surface for the application itself. If you go to the home screen, the initial setup is restored. What you also have here, you have a plus button on the bottom of the area, which is used to add widgets. So now we can start the web widget, for example. Now the application has been started in the background just because we added the widget. So it's another functionality. So, and if we close the application, dismiss the widget from the home screen, the application will still run in the background. The widget selection is also persistent. So if you stop the Neptune UI, then the selected widgets will be restored on the next start. Let's try this. So now we have again the calendar and the phone widget running again. So maybe you should memorize it. Some people get confused if they start Neptune and it doesn't show the widgets which are shown in the documentation, or maybe they have seen somewhere else, so the selection of widgets is persistent. Welcome to the screencast about the system dialog as a part of Neptune UI in the Qt Automotive Suite. Let's take a look what system dialog provides to the user. You can open the system dialog by pressing the Qt button on the bottom part of the Neptune UI, and it opens with 4 tabs. So the first tab is by default the system tab. We'll come back to this tab later, and now take first a look on diagnostics, and then talk about the apps tab, and then take a look on system and performance tab together, because they are slightly correlated. The diagnostic tab provides a dump from the console when running the Qt Diag app, which is provided in many builds from Qt. And this utility provides different technical information about the Qt build used, different environment variables used by Qt at runtime, as well as many other technical details which are useful for diagnostic purposes. Certainly this tab can integrate any other output from any other utilities which can be installed on your system, or a system from the user. If you go to the application tab from the system dialog, this tab is a kind of aggregation of the controls of the apps. So as you probably know, Qt Automotive Suite is a multi-application, multi-process system which can run several applications in different processes, also on other desktop systems like Windows and macOS, or maybe even on embedded targets which do not support Wayland and compositing. The whole system can also run in a single process mode. But here we can see the list of the installed applications. So basically all applications are listed here, and some of them are also containing and showing different parameters. This is the applications which are running in the background. So if we take a look on the music app, this entry also shows that this app has 2 content windows. So there's one on a center console, which is actually represented by the widget here in the middle running in the background. Plus there is a content on instrument cluster, which is this cover flow plus the one of the songs loaded in the music application. So as mentioned before, the whole application window stretches and can be shown in the full screen, which we will also see with some other apps later. And what is possible for these separate windows is to turn the performance monitor. We can turn it, for example, on the instrument cluster window. So this performance monitor starts showing, basically starts rendering, so does intensive rendering, because currently the content of the music app window here is static, so it most probably doesn't render anything, but you need to measure this somehow. So we implemented this trick showing the rotating rectangle, and we also count the number of frames per second which are rendered on the screen for rotating of this rectangle. So generally these numbers should be taken with a certain grain of salt, with a caution, because the main use for them is to detect some anomalies in the system, where some parts really running suspiciously slow or really are very slow in the rendering, because the implementation of the performance monitor also requires some rendering power, and it is not always precise on digits. You can also turn on the same monitor on a center console window. So if you close the dialog and take a look on the widget from the music application, you will see small numbers here on the top. And if you resize the application in the full screen, you will also see this in the full screen view as well. So let's go back to the home screen and open the system dialog again. What you can also see here are controls for stopping and starting app. So on the right we have this cross buttons with a cross icon on it. So if I click now on music, it will be stopped. So it is stopped here on home screen. So the widget is dismissed, as well as on a cluster as well. And there are some other controls for this. So we can go maybe to the HUD and instrument cluster apps. There are controls for auto start and auto recover. So with this you can define if certain apps will be started, automatically started on system startup, and that they will be launched again if it happens to them to crash or something else happens with them, so they need to be restarted. So now both of them are activated. So if I close now HUD and instrument cluster, they will be relaunched after a while automatically. And you should also not forget, the same way as you maybe heard in a section about a screencast about the widgets, this selection is persistent. So if you once select something to auto recover or auto start, this will be retained on the next Neptune start. Now we can go to the performance tab. And this tab provides actually slightly comparable monitors, but these monitors are for the entire window content of the system UI. So you can turn on the same monitor for the center console window of the system UI, as well as on instrumental cluster. So they are useful to measure the overall system performance and not the performance of the actual separate application. So we can now turn them off and go to the system tab, which also provides some performance information, which we can talk at the end. And there is other section of information on the bottom, which is also useful for diagnostic and debugging purposes. It provides information about the underlying operating system. So as you can see, I'm running this on Ubuntu. It also provides information about the used Qt version, OpenGL used. It also provides information about the versions of components used, information about network connection, including the IP address, which you can also use to create a SSH connection and connect to the device when the system runs on an embedded target. And there are some overall performance indicators from the whole system. Another interesting element of the system tab is the information about startup timings. Currently it is not populated with any values because by default this variable is not set. What we will do right now is to stop Neptune and set this variable and see how the startup timers actually work and which information they provide. So let's stop the Neptune and let's set the environment variable. So you can set it to 1, or you can also use as a value a path to a text file, which will be used to dump the log from the timers. So we'll not do it right now. It's more useful if you do it in an automated way and always like to have this logging file. So I'll just set it and start Neptune again and return to the console. So if you scroll up, you see the output from Neptune. So it first starts to measure the startup time which was used to initiate and start the system UI, basically the whole system from scratch, and actually starts counting the time from the time point before the main function or main was entered and executed by the system. So this is also important to, especially on embedded system, to understand the loading of the executable on embedded system. So it goes through different, so first starts the system UI and then it goes through the list of the apps which have been set to start automatically. So it shows different elements, what was started and how much time this did take. So if we go back to the central console window and open the system dialog again, this shows us the overall time from the boot. Actually, it's very high right now because it shows the boot time of the entire notebook, and it runs for a certain while meanwhile. But it also shows in the second row the startup time from the Neptune UI and system UI process itself. So it took slightly more than half a second to start it. Yeah, this is all about the system dialog, and talk to you next time. Welcome to the screencast about general settings as a part of the Neptune 3 UI in the Qt Automotive Suite. Let's take a look what general settings actually provide. You can open general settings by clicking on this gear application icon button. It has different sections, so it allows you to change languages. Now this preset, I think this should be Korean. No, it is Japanese. Sorry, I don't speak those languages, but we can switch it to German. And as you can see, it switches languages on the fly. It also considers the locale. So if we switch to American English, the time will be shown in a AM/PM format, and it doesn't require any restart of the application. So all applications running in the background will get a signal from the system UI that application language has been changed, or locale has been changed, and will act accordingly. What it also allows on the language section is the mirroring of the layout of the application for those languages which use right to left writing. So if you select Arabic, for example, the UI will mirror. And if you now go to the home screen, you see that the home button is also now on the right side, not on the left side. You see that the widget area has been also mirrored, as well as layout of the content of the apps has been mirrored as well. So let's go to the setting as well. So as you saw, it doesn't require any restart of the applications, so it all happens in the background and on the fly. Maybe you can go to the themes section, theme and colors. It's one of the two elements of the visual styling which you can use in Neptune. So we currently provide two themes. Is a dark theme which is currently activated. You can also switch to the light theme, which is then applied to the central console and to the cluster window. The head-up display theme is certainly not changed because you still want to have it with the transparent or maybe black background, because it is then projected on the actual system on a windshield surface or any other surface, so it should not change the background. Let's go back to the black theme, dark theme. What you can also see here is the change of the accent color. The accent color is controlled here, so you can also select different accent colors, and they will be applied also certainly in both themes. Switch to the dark one again. Yeah, this was basically it about the general settings app. In this part of the screencast about Qt Automotive Suite and the Neptune 3 UI, we will take a look on few features which are not so visible. They are kind of under the hood, but pretty handy in the use and can allow some actions on the UI which you can use in your setups maybe as well. So one of these is using the keyboard shortcuts, and speaking of this, maybe we can take a look on the docks again. I was mentioning the docks before. Docks are pretty useful as well, so they contain quite some information which I'm not covering here in the screencast. So if you open doc.qt.io, there is a section about solutions, and there is another subsections about Qt Automotive Suite. We have now 5.13, so 5.14 is not published yet. It's in the work yet. So let's take a look here. So if you go then to content and select components and tools, Neptune 3 UI is in the section reference UI, and then there is a section general overview, and then on the left side you will see a small subsection about keyboard shortcuts. So this is the shortcuts which are currently available in 5.13. There will be a documentation update for 5.14 on this, but let's try to some of those shortcuts now on the Neptune running here. So first of the shortcuts I like to show is actually Control-C. So as I currently see now in the cluster, there is no application content. It's actually hidden because Control-C was pressed. So by default, you will see the music application running on a cluster. It is also currently loaded as a widget. But if you press Control-C again, you can switch between this so-called, or so to say, empty mode, where there is no application content shown, and then if you press again, the music view will be shown. So it kind of cycles through the applications which publish their content on a cluster. So if there will be a third application or another application who shows this, it will continue to cycle. So when we talk about these applications, I will also show what they use on the cluster, show on the cluster, and I will be using the same keyboard shortcut just to switch around it. For the cluster, keyboard shortcuts are certainly a good point because the cluster doesn't accept touch events, so keyboard is the only way to control them on real hardware, as well as you can control the cluster on the companion app, but we will mention the companion app and take a look on this in some of the later sections. What we also use with keyboard shortcut is actually creating screenshots. And for screenshots, we also use a special event or action on the screen. So basically, there is a screenshot, keyboard shortcut for screenshots, plus this event. So both of them are pretty useful because sometimes, for example, in debugging, there might be a situation on the UI where you cannot press anything. Basically, there is a crash or something else happens on the UI. So for this, you might need an keyboard shortcut. But in cases you don't have a keyboard and you have just a normal UI view and just wanted to capture this also for documentation, and we do use this for documentation as well, you can press and hold the values for the clock on the right top side and keep it pressed for longer than 3 seconds. Just saw the notification for this. The same happens if you press Control P, so it's Control Print. So Control P, now basically I had made another screenshot, and if you go to the console, this is actually posted here right now, even on the console where we started Neptune, you will see the message that they are posted to the TMP directory. So the directory is, by the way, also selected depending on a standard queued path. So on some systems that might be a different directory, but at least here on Linux, this is /tmp. So if you go on the /tmp and take a look, list all files from today, so they all have a name taken from the date and time. Let's list all of them. So you will see there are 2 screenshots made from the central console, one from the cluster, and there is a dump of the text file, or text information. This is taken from the system dialog, which we already took a look on. So on the right side, there is a dialog page, the diagnostics page, sorry. And then there is also on the system tab, there is information about the versions and the platform where the Neptune was built and running onto. So this is also dumped to the text file. So we also use it internally for debugging purposes as well as to report bugs. This was it, and let's talk about other features in the next parts of the screencasts. Another topic to take a look on is the settings persistency. Settings persistency is one of the important features, since certainly end users expect that their selections will be restored on the next system startup. In Neptune, we store some of the user selections persistently, and one of these is the selection of widgets on the home screen. To try it out, we can just go ahead and, let's say, delete the music widget from the home screen. Then we can go to the console, stop Neptune, and start again. As you can see, the widget is not there anymore, so our selection has been restored. In Neptune, we use standard Qt features for Qt settings, which store settings in the file system. Location is defined by Qt standard path class, and is different on different platforms. On real embedded targets, probably there will be other solutions, because using the file system for this purpose actually wears the flash chips, and some manufacturers use, for example, database solutions which store settings or store values, but then flash the database files only on some regular basis or on some event. One thing maybe to take a look on as well is the allocation of the settings. So as I mentioned, we use Qt standard path class, and it preset default values for different platforms. So settings are stored in a category app config location, and on Linux, for example, which I use for the demo, this is in home folder, in the folder .config, and then application name. So let's take a look on the console. So this will be in home. Let's first stop Neptune. So on the home location, we can actually also remove this for the next demo. It is not a standard procedure, certainly, because usually you should not remove these files manually. So home folder .config, and then application name. The application name is actually composited out of the organization name, and the application name also goes as the name of the file. So there's only one file in this folder, but we'll just go ahead and delete the entire folder. Basically, this will reset all settings to their default values. Another topic to take a look on is the configuration file of the Qt Application Manager. It is used not only to preset some values for application handling, but it's also used by Neptune 3 UI to store some properties and other values used then later in runtime. Let's go ahead and open the console and take a look on the file. So we actually can even open this in a editor, because we'll change a few values later on. So let's scroll up to the beginning of the file. So the first section is about applications, basically the path where they will be installed and some other values. Please take a look on the documentation of the Qt Application Manager, where all this is documented and described. We'll scroll down to the section called System Properties. This section belongs to, or is used by the Neptune 3 UI, and it contains a few values which are then later available as QML properties in the system UI and generally for the system-wide use. One of the properties we will take a look on is the def mode property. This property is interesting because it also allows to enable and disable features which are available or not available in production and development versions of the software. So the advantage of this is that you can disable some development mode features just by changing the configuration and not changing the source code. The def mode feature is used in Neptune for one application, and this is the Sheets app. The Sheets app is an application for development purposes, but it's also interesting to take a look on because it actually shows the entire selection of the UI control used in Neptune. So there are 7 sections of different kinds of controls. They're all live, basically implemented in a or used in a real application, and the use case for the application is exactly for the purpose that the developer would open the app, see how a given control actually works and looks like on the screen, then go to the source code and take a look how it is implemented and how it can be used in a given app. So if we now go ahead and change this property to the value of no, store the configuration file, and then stop Neptune and start it again, we will see that the application is not available anymore in the launcher, so certainly it cannot be started by the user. So this setting can be also used for some other features, as well as generally the application manager configuration file can be used for other properties of any values which you could use in your development. The configuration file of the Qt application manager is also used to store different values which specify which style will be loaded when the Neptune 3 UI starts. In Neptune 3 we provide 2 different styles which are implemented on top of Qt Quick Controls 2. The implementation is done in C++ and QML. C++ implementation allows to achieve quite better performance in rendering of the UI. Let's take a look how this is specified in the configuration file, and let's take a look on the configuration file which contains the standard Neptune values. I didn't use this file actually to start Neptune before, because if you didn't use the configuration file, by default this file is taken. So if you open the file for viewing and then scroll to the UI section, you will see there is a value for style which defines the path where the style is located, as well as there's a possibility to switch between icon theme, and this theme is named Neptune. So if you now go to the Lucy style, scroll to the UI section, you will see that there is a different path for Lucy, as well as the different name for icon theme. What you can also see here, these are variables here on the top. Let me scroll up. These are environment variables for Qt file selectors. Qt file selectors is one of the cool features which have been recently introduced. They allow to load different QML components depending if this variable is set, and files are stored in the folders with this prefix. We'll take a look on file structure and where its files are located later, but now let's take a look on a Lucy style. I'll start just one more Neptune, which is pretty much unusual, but instead you can now take a look on the difference in the implementation. So let me shuffle a bit windows around first. So as you can see on the central console, the look of the home screen is slightly different. So especially the widgets have been made in a different way. For example, there is a different icon to close the widget, which is on Lucy on the top right side, and the Neptune is in the corner of the bar on the side. The bar itself is also different, but the most prominent difference is actually on the cluster. Just resize it slightly that it has the same size. So the cluster implementation is entirely different. So there's Gotch in the middle, and this is only one, and other values are placed on sides. So this difference in application implementation is actually allowed and powered by file selectors, because then when this instance of Neptune is running, it takes files which are placed in a folder which is prefixed with the name of Lucy. So now if we go to file browser, so this is the build folder of Neptune. And if we now take a look on the cluster app, we can see that there are different icons for the battery and the distance. And if we can take a look on a folder of panels, there are different panels, which is actually the dial power panel and the speed panel. This is the parts which I mentioned before, which are different. And there are some other differences in other folders, because there's certainly different implementation also in other apps. Speaking of this, maybe we can take a look also on the folder structure of Neptune. What I like to underline here is that we invested additional effort to make sure that we have a clear split of assets and a source code. For application, this will allow switching the visual appearance, as you now can see, in the style and the implementation. So basically you can provide one tarball with the code of applications and the system as whole, and then provide another tarball with assets and switch between different visual appearances on the same implementation. As you can see, there is a specific asset folder in import shared, as well as there is a folder for styles. So this contains the implementation and the pointers to the Lucy and Neptune style, and some other folders also contains a split over assets and code. Yeah, this is basically it about styling, and talk to you next time. Yeah, welcome to the next part of the screencasts about Qt Automotive Suite. In this part we will take a look on some features in the UI which are not really visible. At least you cannot connect them to certain features provided by Qt Application Manager if you don't know the background. And all these features are about different forms of inter-process communication and interaction between applications and the whole system, including the system UI on the screen. So the first thing which we will take a look on are notifications. We saw notifications a couple of times before, and especially I think they showed up the first time when we talked about general settings. So each time you change a language, there is a notification popping up from the top, telling basically that the language was changed. You also see here a button which opens the notification center, and also close it. And notification center lists all notifications which have been received in the past. You can close them separately. You can just clear the entire list. Notifications are provided via an interface in Qt Application Manager, and Qt Application Manager uses a free desktop standard for this. So it also acts as a server on a dbus. And what happens on the application side is actually that application sends a notification as a message on the dbus, which is then picked up by the system UI running together or combined with the application manager, as in the case of recent Neptune, and then displayed on the screen. This flow is, I would say, from the system architecture, is almost mandatory, because applications are shown on the top of other content, on top of the system UI. Maybe there is another application running in the background or underneath the notification message. This is why notification should be managed by application manager as a central component in the system UI. Another feature, and I'm going for this in the music application. Another feature, pop-ups. Pop-ups also display information from a given application on the top of the content from the rest of the screen or other applications, but they, at least in Neptune, they shown in a modal way, so the user should always close them or confirm a pop-up by an action. Pop-ups are used for the general volume settings, which we saw it. This used in the console or climate app, sorry. They're also used in a system dialog, and you always see this button which you can close the pop-up with. What I like to talk about as well is, let's switch back the UI to English again. Let's take British one because now we get temperature in Celsius. For the music application, there's another aspect. It also uses pop-up, but I'd like to address something else in the Qt Application Manager. So if you open sources, then you will see a pop-up where you can select the source, and then you select the AM/FM radio, and then the radio application will be started. Here again, you can also select the music application, and the music application will be started for you. So these actions are taken or activated from a given application, and then a request is sent via the application manager to start another application. So application requests are, as a term, it's used in Neptune as a collective term because Neptune uses two interfaces, two techniques implemented in a Qt Application Manager. So this one is based on a MIME type handler in Qt. It is also based on an open document interface in Qt. So basically you can define or register an application under MIME type handler, and you can open this application either by MIME type or along, or with a document as an argument attached to it. What happens, how it is used in the letter form. So if you go to the Sheets application and go pop-up, the pop-up notifications, then there's an application with application request. So this one also uses MIME type handler, which transfers also information. Now we will open the Maps app. Oops, I'm too slow. Open the Map app, and the Map app will be opened with a certain coordinates. So an example sends us to Athens. So the request to open Athens in the map was provided as an argument for the MIME type handler. What is also used in Neptune, and this is another part of the application requests, are intents. So intents are a bit of heavier, more difficult to show them here, such as screencast. In the recent version of the Neptune, intents are used for almost all interactions on the system UI. So the entire launching of the apps is based on intents. Commands in the vehicle application are based on intents. Also, scrolling the music application is also now migrated to intents. Intents are more advanced technique in this inter-application communication. This is a technique also allows an application to register multiple actions or intents. Basically, intents is also, as a term, is also known in Android development. There are also intents, and Alexa also uses intents. So an application can register different actions as intents, which it provides to others or to the system UI as a kind of service, or which it can react to, and then they can be called. So in comparison to open document interface and MIME type handler, intents can also return some values. This is certainly a big advantage for the cases where you need to know the status of the action, or maybe some values or data is calculated in an intent and then returned to your application. The best thing you can do actually with this is to take a look on the documentation of Qt Application Manager. There is an example based on our mini desk series of examples, which demonstrates how intents can be used with Application Manager. I think this case will be much easier to go through and understand than the code of the Neptune UI. Yeah, this was basically it about the pop-ups. And the next topic which we will take a look on is the companion app, which is provided in the Neptune 3 UI. The companion app is interesting from two perspectives. One of this is that it implements really common and popular use case where an embedded system, or a head unit in our case, has an application running on a smartphone where the end user can change settings of the system or even control it remotely via the network. Another aspect is that the implementation of a companion app generally, and the particular app in the Neptune 3 UI, actually benefits from a few architectural approaches taken in a Qt Automotive Suite. So for this, we will open the console. I started already Neptune, as you can see, running in the background in another tab. What we'll now go out and see is actually processes which are running in the background. And as you can see, in addition to the actual Neptune 3 UI process, system UI process, there are also a couple of applications running in the background. We already mentioned them when we talked about the system UI. They run as separate processes, but there are also a set of backend servers which have been launched by Neptune when it was started. These backend servers, as well as the libraries which are used to develop the UI, so they provide QML plugins for UI development. They're all based on a common set of APIs in the middleware. Some of these APIs are auto-generated, or the code for these APIs is auto-generated from IDL files. And the code is also using Qt remote objects, which also enables to run the background services out of process with the UI, where the UI talks to the servers via the network. The same the companion app actually does. So let's start the companion app. It is provided in the same folder of the build, or if you use the installer, it is provided in the same folder where Neptune actually resides. So started here. So the first screen you will see if you launch it, it is a prompt to enter the network address. By default, this shows the local address, the loopback address of the machine here, but you can enter any other IP address of the system where the Neptune 3 UI and backend servers are running. So let's connect here. And if we connect, the first thing you see that it actually reflects the values, the same values as they are shown on the cluster. And the first tab shows you an overview of the vehicle application and a few controls which are provided for the vehicle application. So you can, for example, go out here and close let's maybe first switch to the view on the vehicle application in the cluster. You can go out and close the sunroof, so it will be also closed here. On the media application tab, you can control the media playback, for example, switch between the songs. Let's switch to the media view, switch between the songs. On the maps, you will see the progress on the route. On the settings, you can change the settings of the UI. So most of these settings are also available in General Settings app. So for example, we can switch the theme. And the last tab actually implements a few settings which are unusual for a use case for the end user. So certainly, for example, changing the telltales, which is also possible here, is not something what an end user application will provide, but it is convenient for development purposes where we, for example, can control the content shown on the cluster without the keyboard. Usually you will do it with a keyboard shortcut. And also you can see on the bottom here the version information about the app and the system which is used to build it with. That's it. So in the next section we'll take a look on the cluster, and the cluster actually also uses the same environment, providing quite some features on top of this. Thank you. In this part of the screencast about Qt Automotive Suite, we will take a look on the cluster. And actually there will be two more recordings about cluster related topics which will come later. So we now have already Neptune running on the screen, and as we mentioned in the previous recordings, cluster is one of the top level windows on the desktop On a target, it takes the whole surface of one of the connected physical displays, and the cluster display surface is managed by the system UI as a compositor. The cluster app is a separate application in the Neptune 3 UI. So what we can do just to start is to go to the diagnostics pop-up and stop the cluster. Now you see that only the central area, which is the music application, remained for a while, and now the cluster shows up. The reason for this is because the cluster is set to auto recover here. Basically, each time any of the application, and you can set it for any of the application, crashes, it will be automatically started again. So we can maybe turn it off for the next topic, and you can also see here there are settings for the auto start application. We talked about the settings when we talked about the diagnostics panel. So these settings define if an application will be started automatically when the whole system starts. So let's close the instrument cluster application again. Now you can see again in the middle the window of the music application. Maybe, and I hope you can see it on the recording, the window actually stretches over the whole surface of the top level window of the cluster, which is reserved for the cluster. And this window belongs actually to the music application, which runs here. This is here in the middle, in the background. And this can be done and shown by any application which sets appropriate window property on this window, and will be automatically then shown for by the system UI. So let's go to the diagnostics panel and start the instrument cluster again. I will also now set the auto recovery option. What we also provide is the view on the cluster on some other applications. So let's take a look on a few of them for the demo purposes, and I will also comment about some details around them. If you remember, there is a keyboard shortcut where you can switch the content of the cluster view. So this is Ctrl+C, and currently we have just two views. Basically, this is a view of no view where no application content is shown. This is currently on the screen. Now we have music, so if you keep pressing Ctrl+C, the view will cycle over the next application over, and then sometime also hit this no application view. So now we've gone to the vehicle application and started. This is also presented here as one of the views. You can also see here that the gauges also became slightly smaller. So they reduced in the size, so that the use case for this is the user will see more of the application surface and less the surface of the gauges. And certainly you can also keep using these controls we provide in the vehicle application, like open the sunroof, open the doors. And then you can also switch to the next cluster view. What is also supported is the cluster view for the maps, for the map application. Start it now. And you can also switch to the view on a map application. Here is Ctrl+C, and you can basically keep cycle through the views all over. What you can also see is certainly the so-called telltales, which are shown on the top. They belong to the view or to the layer on the cluster, which also link to the gauges. So if you stop the cluster application, they will be also dismissed. The telltales as well as the values on the gauges are a part of the simulation. And the simulation is also one of the features we added in some of the recent releases. In the current release, you can also use actually QML to write the simulation code, and we can take a look on this. So I'm opening now Qt Creator, and if you go here to this is the source view of the Neptune 3 UI code repository. So if you go to the source folder, there are two folders with drive data. So the drive data is the data which is shown mostly shown in the cluster. So we've got here drive data qphase file, which defines the values in the cluster, and we auto-generate the source code for these values. But there are also two folders we can talk about. This is backend simulation and backend simulation server. This may be slightly confusing on the first run, but the difference of them is that backend simulation is a simulation which can run inside of the cluster application itself, and the drive data simulation server is a simulation which actually runs on an out of process drive data simulation server. So it's a part of the server. So advantage of this that the server can run on its own, and the cluster view just renders and represents the data which is changing on the server side. So it's a more kind of realistic scenario where most of the backend components are running out of process and are implemented separately. So if you open the simulation QML file, you will see that, let me scroll to the top, it is a regular, so to say, Qt Quick QML application. It basically contains two timers. One timer is changing the status of the drivetrain. There is also a timer changing the speed, and as well as changing the set cruise speed as well as the speed limits. So this is what you see on the, let me switch to back to Neptune, what you see here on the cluster window. What you can also see is the changing value sets of the tails on the top, and this is done on the next section of the simulation app, where you just have a timer with some random values, and they are changed all over all 3 seconds. Speaking of this, we can take a look on another capability of the cluster system, or let's say Neptune 3 UI, is namely the cluster application which we have added to the 14th release, and this application is something special. So we will talk about this in the next part of the screencast. In this part of the screencast about Qt Automotive Suite, we will take a look on the Neptune cluster application. This is not the application you can currently see here on the top level window or for the cluster. This is a new application we added in the 5.14 release, and this application covers a different use case. So this application allows to fetch the values and create a UI for the cluster application on independent platform or independent board, which this board will still talk to backends via the network and provide the same values as shown in the cluster app, but can be run differently. So I will describe the usage scenario a bit later in more details. Now we'll take a look on the environment, how we can start and try it. So when you start Neptune, let's open another terminal. When you start Neptune, it automatically starts in the background backend servers. What we now need is basically start them manually. So let's first take a look which servers are running in the background. So there are 4 servers running in the background. We'll now need all of them because we actually are going to stop Neptune entirely. And I prepared here a command line which we can start all the servers in one piece. This will to save a bit time of typing. Now they're running all together in the background. What we will do now is actually to start the cluster app. It is provided as a part of the build here. So let me resize it a bit. It's really kind of starting large. What you can see is here is a very similar application as you also see it on the top level window of the cluster from Neptune 3 UI. And this application also shows the same values. They are fetched now from this servers running here in another tab in the background. And this application also shares assets and central components from Neptune. But this application is a standard desktop application written in Qt. What we have added here in addition are buttons. You can control this application with a mouse or a touch screen compared to the cluster app, which accepts only keys, keyboard shortcuts. So we have got a view on the vehicle application, there is a view on the map, and there is a view on the music. So what we are going to do now is, let me make it slightly smaller and place it roughly somewhere here. So what we are going to do now is actually to restart the Neptune the way how we had it before. So what will happen now is that Neptune will try to start the servers in the background again, but this is not gonna work because they're already running. So let me resize the top level window of the cluster. So this is the standard cluster from the Neptune, which we know already. And let me fetch the head-up display window as well to make it complete. We're almost there. So what we currently see here is the separate cluster application running in parallel. It fetches the values, the same values from the servers running in the background, and it also shares the content on the values, as I mentioned before. So we now have here music application. What I can do is to launch the vehicle application, and this content now will be reflected on the cluster application here, a separate one, and on the actual cluster we still have the music. In this part of the screencast about Qt Automotive Suite, we will take a look on the integration of the Qt Safe Renderer in the Neptune 3 UI. And before we start, maybe as you see, we don't have Neptune 3 UI running already on the desktop as we had it in the previous parts. The reason for this is that because we will proceed slightly differently. If you remember from the previous part, we also started the backends used by Neptune separately from the command line because we had a look on the desktop cluster application from Neptune. And we will also need the same here because the QSR application for the desktop also connects and works slightly similar as the cluster application. So basically it connects to the backend services running in the background. And compared to the cluster application, it uses the infrastructure provided from the Safe Renderer to emulate rendering of the safe content on the desktop, but uses also this infrastructure to implement the entire pipeline, like Heartbeat, for example, and also elements for safe text and safe image from the QSR directly in the desktop application. So speaking of this, I would like to refer once more to the documentation provided with the Qt Automotive Suite. So this is the home page of the Qt documentation. You can click here on the Qt Automotive Suite link, and the home page will point you to components from the whole package, and Safe Render is a part of it. So this link points directly to the documentation of this Qt Safe Render itself. If you go to the reference UI section and scroll slightly down in a section about application insights, there is a special page about Qt Safe Render integration. So if you go here, you can see a diagram how it works. So you should really take some time if you are interested about this topic and take a look on details. But let's return to the demo. So here I already prepared a long command line here with the whole servers which we used in the previous part of the demo. So we'll start them in the background, and now we will start separately the application, the QSR application. So this is called Neptune 3 UI QSR. So this is the initial view on this. So it is also a transparent window. So as you can see it, you can see the background of the window, basically the content, and underneath it, also through the top level window. So I will place it somewhere here so they can continue. Now if we switch back to the Neptune tab and start it, one thing we should also not forget, I actually did this already, is to enable QSR support in the configuration file. So it is also noted in the documentation. And now, just for the sake of the compact way to show the screencast, I will start Neptune right here. So that we have already changes in the configuration file. So what happens now is that it is slightly confusing, because now you have the transparent window of the QSR on the top. But if you move the cluster window on the desktop, you see that the window from the QSR actually follows the cluster and tries to align it as close as possible, so that visually it appears being the same application. So what I will do now is align it on the top. And what happens actually, just to explain maybe before, we will crash Neptune here and see what happens. Now the cluster application in Neptune fetches the data from the backend servers, as well the QSR overlay actually does. So if we now stop the crash with Ctrl+C Neptune 3 UI, the display content of the QSR overlay will change. So it brings the message that error occurred. Certainly Neptune is not running anymore, so the connection was broken. And this is also using the feature provided from the Qt Safe Render with the heartbeat. So there's no heartbeat anymore, Neptune is not there, and now QSR starts to render the safe content, and we have speed and the portion of the consumption of the electrical power on the right in the background, and their telltales also keep showing. So they are keep being running in the simulation. And in the background, actually by far, certainly faster than I'm speaking here, some service should start Neptune again on the top of it. So now Neptune restarted, and we got the previous, should move the cluster, not the overlay. And now we return back to the normal situation where we have cluster now and Neptune running. And the content of the overlay has changed, because now if we move the overlay away, then you can see that it renders the safe content, but also the Neptune resumed rendering the same content in a non-safe way. This is basically it about the desktop integration, and let's take a look how it works on an embedded target. Okay, in this part of the screencast about Qt Automotive Suite, we will take a look how the QSR, Qt Safe Render integration works on a target. In the previous section we already saw this, how it works on a desktop. On target it is slightly different, and this is actually much closer to a real use case. Here the QSR application is integrated in systemd as a systemd service, and works together with their actual startup of Neptune. So we're going to try it out. So I have here two terminals. The Neptune and the Qt Automotive Suite now run on an embedded NUC target, which you can see in another two video streams on the screen. And I have here the desktop just with the terminals. So I'm going to log in on the target. It's remote shell. So I have two terminals here because in one I would like to show messages from this journal, system journal, which will show how systemd actually reacts. The systemd configuration is made the way that if the Neptune process stops or crashes, basically, it actually works only on some crash exits, or exits when some problem had occurred. In this case, immediately another service will be started, which then launches the QSR application. And then if the Neptune service will be restarted, QSR application stops and shows up again on the screen. So this will show up here on a terminal, on a below terminal. I started listing from the following the journal on the system, and also grabbing this for systemd messages and messages from Neptune. Unfortunately, the journal control utility doesn't support pattern matching for the target, so I need to do some tricks with grep. And here we are going to check the actual process number for Neptune. So this is the one I'm getting. So let's crash it with segmentation violation. So stopping this, and now you should watch what happens on the other screens which show the target. So now we see quickly a terminal, and then the QSR application is launched on a console, on the cluster display. And by default, you actually should check the configuration on your target, because we currently have, let me also show you this here. So you should check which name is used for the QSR KMS integration. So I had to change it to DP4 because this is different in my configuration. And you should also compare this with your configuration, because it might be different from the default one. Yeah, so this is the QSR running. So now we will start Neptune again. And now the QSR application will be dismissed, and the application Neptune starts again. It also resumes the simulation. In the beginning you saw a brief animation, startup animation. It certainly can be disabled in such cases, but the values which have been shown, they have been taken over from their background, the backends running in the background, and the values have been resumed to be shown on the screen. And let's take a look what's going on here on a journal control utility. So we basically have a message that Neptune service failed. Then there was a message that Neptune QSR service was started. And then there was a message that Neptune 3 UI service was stopped because Neptune was started, and now at the end we have Neptune 3 UI service running as normal, as usual. Yeah, that was it. Thanks for your attention, and let's go to the next part. Welcome back to the screencast about Qt Automotive Suite. In this part we will take a look on some details in the Maps app. So we already saw the Maps application briefly in some other parts before, and we saw that it can render a map view on different displays. I like to talk about some details in addition to it, and also show what application can actually do in addition. We certainly will start with launching the app from the application launcher. Now you saw the brief message from the notification center that we have got an online map. We actually had some situations or some cases where we need to supply or need to support a case that the device or the desktop should keep working in a case that network is not available, and still yet in this situation the map should be shown. The reason for this is also that we're actually fetching the map data directly from the server from Mapbox, and the entire implementation is based on a plugin for Qt location for the Qt location module in Qt provided by Mapbox. We use this, and the implementation is based on live data from the network. We also provide an offline map for the cases that the system runs without the network connection, but this cache is provided only in the Lite theme. And speaking of the themes, you also maybe notice that the map view is leaned or adapted from the visual perspective also to the black theme of the entire UI. This is also a special extension or customization we had made, also based on APIs and features provided by Mapbox. And one point I also wanted to mention is that you can search for a destination and even start a navigation in an app, and this is something what we are going to do right now. So I actually just was thinking that this search box, so if you press the search button and text field will open, I think this should be the only text input field we should have in the entire UI. So the rest of the UI is based for touch screens and can also be used with a mouse. And here we have Qt Virtual Keyboard shown. So we also integrated Qt Virtual Keyboard that shows up automatically on any text entry field. I have here certainly a hardware keyboard, but I will now enter a destination or search for a destination with the virtual keyboard on purpose, so to say, just to show how it works. So we are in Munich and going to Berlin, one of the classical routes. Let's see, here's Berlin. And now if you press the directions button, a route will be calculated. Let's see, looks pretty good. So it's one of the optimal routes. What you can do now is start navigation, but before that let me switch to the map view on the cluster. So I'm pressing Ctrl+C right now, as you maybe can recall from previous parts. Now this is the regular map view in the cluster. You also now see that the gauges became smaller, and if you switch to the 3D gauges, they will also be tilted slightly. This is a kind of effect we added. But the whole idea of this is actually to free up more space for the map view. And now we will start navigation. And what you can also see here, so certainly on the central stack or central console, you see a view on the map with the route progressing. But on the cluster, as well as on head-up display, you also see a route guidance. And actually I think the HUD view and the view on the maps window from maps application should be almost the only case where the head-up display is used in addition to the HUD application itself. So it also shows here the route guidance, and this is also a window like the same way as a cluster window with application content, which is managed by compositing done in system UI. Yes, so it will take certain time to go from Munich to Berlin. I think we will not follow the route right now. And actually, what I should also activate is actually the map widget. It also duplicates the view on a route progressing, but again, as said, the route takes a bit longer, and we'll not wait until we arrive and stop here, and we hopefully meet each other in the next part of the screencast. Welcome back to the screencast about Qt Automotive Suite. In this part we will talk about various aspects of applications in general, as well as about the downloads app, which we didn't take a look on yet, and the plugin for the Qt Creator for application development for Qt Automotive Suite with Qt Creator. As first, maybe we can take a look on the configuration file again. We had it a few times before, especially in the first parts of the screencast. So in the configuration file, you will see in the section of applications there it is also mentioning built-in applications. And this is also mentioned and explained in the documentation of the application manager. Application manager splits all applications in two major categories. Built-in applications are provided as a part of the build and as a part of integrated part of the whole system. Built-in applications cannot be deinstalled or removed. They can be only updated, but it is possible also or done with the same tools and means as the normal application. Just the application package will be installed in the system on top of the available application, and the older version of the application will be, so to say, hidden or shadowed. Let's take a look on a downloads app, and this is the app which provides a way or UI to download apps. And we download apps from another component which runs on the network. This is the component called deployment server, and it provides a set of feeds, HTTPS feeds for the downloads app, which then are listed here on the downloads application. They are split in different categories and have names, so this is all read from the meta information received from the deployment server. Despite of the fact that we can download additional apps to the Neptune, we also see the deployment server and generally the pattern of developing the system in separate apps as a blueprint and our advice for larger projects how to proceed. We also believe that it will make sense to simplify integration if the system is empty in the beginning, and then it will be populated and deployed application by application centrally. And we also modularized Neptune step by step and made everything, the entire system basically consisting of several applications which you can stop or dismiss on the screen. So what I will do right now is just to stop all applications here. You can see also downloads is actually application itself. So let's stop me again. So just to show you the empty screen or the empty system, which also depicts a kind of the beginning of the entire development. So also the home screen became empty. I actually forgot the head-up display. It's still running. So now it's done. It's gone. So now you have the empty system, and you can populate the system with different applications. Again, we can open the download application again, and let's download the same game. The same game is also has been added on kind of on purpose, so to say, to downloads, because this is actually a known application from Qt. It's one of the examples, and we basically just took it over and wrapped in a kind of main file and main application to be compatible and running with application manager, but the code of the application remained entirely the same. So it also should show the simplicity to integrate any Qt code being running on top of application manager with the system UI. In this case, Neptune or a system UI which you have created. Yeah, this is the same game as downloaded here. It's also still shows up on a launcher, application launcher, along with the built-in applications which are pre-integrated with Neptune. So we just deleted them or dismissed them from the system UI, but they are still installed here. So generally you can also define much less built-in applications, and also then go this way that you will install all other applications being just additional also for integration and testing purposes. What we will do right now is go to Qt Creator and take a look how this works there. In Qt Creator we provide a plugin which wraps and integrates tools from application manager which handle package creation, installation and launching of the applications. And we also integrated this with the configuration of Qt Creator. So if you first install Qt Creator from the installer, install the packages, you should go to the kit section, and the first thing which should be configured and added is a remote device if you use a remote target, because this is not certainly pre-configured initially, and if you have remote device it should be added. We currently create on the first start of Qt Creator a special category or special section of the kits which are called automotive and the version number and then the platform, and then it is named being for generic Linux devices. This is made for the reason because we launch and handle applications in different ways than the boot to Qt does. So Qt Automotive Suite runs on top of boot to Qt as the embedded Linux distribution and reference Linux provided from the Qt company and Qt. But there is certain difference how we handle applications. So we create our kits currently on a section, manual section on our own on the first startup. And if I had here boot to Qt also installed as well, boot to Qt will be listed here in the auto detected section. The step which I already mentioned, and I did this before, is to add here a NUC. So I will also show launching of the application on a remote device. So I just wanted to mention that this step should be done. And what you can do on the first steps, just to try it out, is to open Qt Creator Wizard, and there's a special section named Qt Application Manager Project. So you select this category, project category, add a name, and go further in a wizard. You can also select here to create skeleton and basic system UI. I will not do it right now because I just wanted to show an app, but this is also possible, and this is also based on the code of the simple system UI implementation as one of the examples in the Qt Application Manager. You should take a look on this later, check the documentation and go to example sections in Qt Application Manager. There are quite some interesting examples there. So let's proceed here. What we do next is we will select one more kit. So the one for the desktop is already selected. So I will select this one for remote target, and basically we are done. So this is our example. What I will do now is actually increase the font size a bit. Let's do 40, because the example is made for the desktop, and on the recording it is not looking very well because the font is too small. And now we have to check what is shown here on the selection on targets and platforms. So we'll first start with the desktop, and we say desktop kit, and we select deploy to the application manager device. And then we select this, and this is my Neptune running. Let me resize the screen of Qt Creator slightly, and basically after this I can hit the run button, and the application is showing up here on the home screen. It also shows up here on the application launcher as a new entry, and starting with the version 5.14 you can also delete these applications via the dialog pop-up here under the Qt logo. What we will do right now is actually switch to the device, and now you should take a look on the two other video streams running in parallel with this recording from the desktop. I just turn on the recording, so I'm switching over to the kit for the device, and we keep the deployment target as deploy to application manager device, and now we'll let the same application run on the device. So certainly it is showing up here, and you also see the startup timings from the application, which we also pre-configured in the configuration of the sample application. So you can also stop the application remotely from the Qt Creator. Yeah, this was basically it, what I wanted to show from the downloads and application and integration with Qt Creator. And in the next section, in the next part of the screencast, we will take a look on some special applications we also provided, but they come on top of the standard installation of Qt Auto. In this part of the screencast about Qt Automotive Suite, we will take a look on a special add-on which has been implemented in the Neptune UI, and it is based on a new component, new module, Qt module, which is currently hosted in a Qt Labs project space. And this module enables cursor navigation on a touch UI. So as you probably noticed, and certainly you know, the entire UI is made for touch displays, or it can be also controlled with the mouse. This is what I currently do on the desktop. On embedded systems, and especially also in automotive, sometimes it is very handy to have a possibility to control or navigate through the UI just using hardware keys. This can be just cursor arrow keys, or it can be a special hardware provided with some additional keys, which is mapped then to some key events then later on Qt. QML and Qt Quick provide handling for this, which is a newer version of Qt called focus scopes. So you can add a property and define that a given item now receives the focus from the keyboard. But this requires change in the source code. Basically, if an application should handle, for example, cursor key events, then all items should be routed and designed to be logically connected. So if the user presses, for example, the arrow down key, then the UI will, so to say, virtually scroll down and activate, for example, an item which is then visually down on the screen, for example, down from the home screen to the enlarged touch area here, or right from the home screen to the button with the vehicle application. This requires quite some code changes and also quite some work. What will be handy, we believed, is to have an automated system for this. And we created one with the plugin for Qt, which is called Cursor Management. I'm just showing actually the repository on Qt Labs, also for you if you like to take a look. It can be compiled and should be then installed as a module on top of Qt. And if you like to try it in Neptune, then you have to open and modify the configuration file. This is what I will do right now. So there is a special setting, cursor management enable, set to no by default, but we will change it to yes now. Save it and restart Neptune. So let me resize and move this screens a bit. What you have right now on noticed, there is a marker, the circle in green. It uses accent color set in settings, but this currently shows the item which can receive input events and also keyboard events by default. So now unfortunately the recording currently doesn't record which keys I'm pressing, so I will just comment what I'm doing. So but I'm now not moving mouse, as you maybe can see it, so I'm using cursor keys. So if I press now right, then it jumps automatically to the button of the vehicle app, then general settings come, calendar, downloads, and the launcher. So if I press down, then it scrolls through the widgets and enlarge buttons, because they are the next items on the direction down, or certainly direction up or left, which are on the layout. So the plugin automatically traverses the layout of the items on the screen and calculates what will be the next logical item on the screen, which will be then on the right or will be on the down. So you can jump also from the calendar icon to the next area, which is then can receive input events on a down direction. In Neptune, this is all integrated actually in a style. So the style receives property change from the configuration that the cursor management is now available, and activates this automatically. So for applications, even this small change, and if you check the documentation, you will read more about it. Just a few properties you need to add to your application to enable it, so it is fully automatic. But in Neptune, again, this is integrated in the style, and it's fully transparent to the source code or to the code of the application. So the application developer do not need to do anything at all, so that the application will be, at the end of the day, integrated in with this feature and process automatically key events. So, and certainly can also, if I press enter here, so I pressed enter, you can also open an application, so it is go back to home. Again, this is the URL of the module. Take a look on this, compile it, and there is a README for it with initial information, but it also provides a documentation and a small example which you can try out. And we will jump to the next part of the screencast, which will be about other interesting application which can run on top of Neptune. Welcome back to the screencast about Qt Automotive Suite. And this part will be about Alexa integration. And this is another optional feature in the Qt Automotive Suite. I'm saying optional here because the runtime which is required for the Alexa SDK is not yet available in the images provided in the installer. So maybe it will be added to some of the future versions, future releases. But the Alexa integration is based on a module which is new. It's not a standard module in Qt, but this is available on the code review. I'm currently showing the page on the code review, and this is the module here. So Alexa is the first integration on top of the APIs. APIs are generally generic, so they can accommodate another integration to some other voice assistants. We just started with Alexa because it seemed to be relatively easy to get started and integrated. I will keep it for a while then on the desktop, but we will switch to the device itself. So the device is shown as usually in two other video stream windows, and we will start with going to downloads and download and install the Alexa app. Then we go to the launcher and launch the app. The first thing you might have noticed is that there is a blue microphone icon which is close to the watch in the top right corner. This is also a button which can be used to activate Alexa if you don't like to use the wake word, but you can also use the wake word and it listens to this in the background if the button is not pressed. The first thing you should do is to check if the right card is selected. So I have quite a few here to choose from. I'm also using here an omnidirectional microphone, which is very good and has a lot of noise reduction and echo cancellation, so we use it on the shows. And yeah, so the setting for the sound card is okay. Yeah, and let's start talking. So maybe I will just also use the button here to give a first run. Alexa, how are you?
I'm feeling really groovy. Got some rhymes flowing through me.
So what you can do is, in addition to standard dialogue with Alexa, so certainly you have a dialogue, can have a voice dialogue, but it is also possible to show cards. So on some answers, Alexa shows some pictures and they are displayed here. Maybe we will do this at the end of the screencast as well. What we also have done is actually the integration in the software itself. What is possible is to control the vehicle app. As you remember, maybe it is possible to open the doors and some other objects in a 3D view on the car. And you can also launch applications with Alexa. And this is something what we will now try and take a look on. Alexa, open Qt car.
Go on.
Open the left door.
Open left door.
Close the left door.
Close left door.
Open the sunroof.
Opening the of.
Open the sunroof.
Open sunroof.
Open music.
Opening music.
Open settings.
Opening settings.
Stop.
Goodbye.
So what you can also do here is, as I said, have a dialogue when Alexa shows some cards. Alexa, what is the weather in Munich?
In Munich, Germany, it's 54 degrees Fahrenheit with mostly sunny skies. Tonight, you can look for just a few clouds and...
Okay, so we don't need to listen to the entire forecast. We can also try another one. It might be more funny. Alexa, what is cute?
Cuteness is a subjective term describing a type of attractiveness commonly associated with youth and appearance, as well as a scientific concept and analytical model in ethology, first introduced by Konrad Lorenz. Lorenz proposed...
Yeah, well, this is not the cute which we are talking about here, but this is cute too. Anyways, thanks for listening, and I hope you enjoyed it and learned about Qt Automotive Suite. And I hope you got some ideas also how you can use this software, this solution, this platform in your project. Take a look on the docs again. I keep mentioning this. There is quite some information to learn and use, and maybe try it out. Thank you.